When we solved equations, frequently you would get an answer like x is equal to 5 because there's only one correct answer, one number that makes it true. That's not what happens usually with inequalities. In fact, almost all the time you're going to have more than one correct answer. Let's try a few of these here and I'll show you what we're trying to say here. Okay, so this first one up here, 2x is greater than 8. I'm going to divide both sides by 2. So we get x on the left side, and on the right side we get 4. Since we divided by a positive, the direction does not change. X greater than 4, we can see that x greater than 4 would be this first graph up here. So normally we wouldn't just say this, we would also draw the graph. Let's try over here. This problem we would add 1 to both sides. So we would get 3x on the left and we'd get 12 on the right. Nothing is happening to the inequality. Now we're going to divide both sides by 3. We get x over here, divide it by 3, we get 4. Again, there's no switching of the inequality because we're dividing by a positive, just like divided over here by a positive. So now x less than 4 would be a picture like this one down here. So we would not only write x less than 4, we would also graph on a number line. Let's try this from the far left. This one we got to be careful of because we're going to divide both sides by -4. Now keep in mind when you divide by a negative, first of all, we get x here. This divided by -4 gives me a +4. But dividing by a negative number switches the direction that the inequality points. So now we're going to say less than or equal to 4. And that would be a picture like the bottom one up here at the top. Color in the 4 and draw an arrow to the left. Now if you'd like, you can check by just grabbing a number over here, like 3 would be on this graph, and put it back in the original problem if you like. -4 times 3 is -12, and -12 is greater than -16. So that we could actually test it out to see if it actually works in the original problem. Middle problem here. First I need to get all the x's on one side. So I'm going to subtract 2x from both sides. Left side becomes 2x plus 2. Right side is now 10. The goal was to get rid of that 2x. We're adding something to both sides. Even though it's a -2x, we're adding so we don't switch anything. Now we're going to subtract 2 from both sides. Again, subtracting doesn't change anything either. But finally, we're going to have to divide. And be careful when we divide. If we divide by a positive, then nothing strange will happen. So this would be divide by 2, and keep the inequality just the way it was to start out. 4 to the left. What if we had decided in the beginning to subtract 4x from both sides? And that's okay because that gets rid of the x's on the left and just leaves a 2. Over on the right, we get -2x plus 10. We are subtracting or adding anything like that. We don't change the direction. Now we're going to subtract 10 from both sides. So we get -8 on the left. We get -2x on the right. Again, we do not do any switching. But now we're dividing by a -2. And when you divide by a -2, we get a 4 here. We get an x here. But dividing by a negative switches the direction it points. X is less than 4, but we still get the same answer for these two problems.